What's happening, folks? Roosh here, and today I'm going to be helping you out with your dehydration synthesis activity. So here we go. If you look at number one should look just like this. It says assemble a monosaccharide, and mono means one, saccharide means sugar. So show me one simple sugar. Number two, it says assemble a disaccharide sugar. It's also considered a simple sugar. But first, I need you to answer this question. The building block or monomer of carbohydrates are... What are the building blocks of carbohydrates? That is saccharides. Okay, and saccharide is just a fancy word for sugar. Okay, so go ahead and show me a disaccharide through dehydration synthesis. Add your second sugar, and go ahead and show me water leaving the bond site. Okay. Moving on to number three. Now it says assemble all remaining monomers into a polysaccharide. So I realize that the bags that you guys have may have different numbers of sugars. So your polysaccharide might have 6, someone else might have 8. All that I'm looking for is that you get the arrangement correct. So your polysaccharide should look something similar to this. Put all the simple sugars into a straight chain, okay, into a straight chain, and anywhere there's two touching, anywhere they're touching, I want you to show water leaving the bond site. And again, remember I gave you this formula. If you add up all the monomers, 1, 2, 3, and 4, if you take the total and minus 1, that should equal your number of water molecules. Okay. Number 4, look up on Google the structure of a triglyceride that is high school friendly. What I mean by that, by high school friendly, is I don't want one that's like an atomic structure. Just find a simple image of a triglyceride. Okay. Before you assemble that, though, I need you to answer these questions. The building block or monomer, the building block of all lipids are what? What is going to make this entire lipid right here? The answer is fatty acids. Okay. Fatty acids are the building block of lipids. For this type of lipid, though, we're going to need one additional piece. We're going to need one molecule of glycerol. Okay? We're going to need one additional glycerol molecule. So, same concept with this. Add up the number of molecules that we have. We have 1, 2, 3, and 4 minus 1. We should end up with 3 molecules of water. Okay? So when this fatty acid attaches, show one water leaving. When the second one attaches, show a water leaving. And when the third one attaches, again, show another water. Okay? Number 5. Assemble a 4 monomer protein. Okay? So we're going to make a protein that only has 4 monomers. First, I need you to answer this question. The building block or monomer of proteins are what? That would be amino acids. Okay? So the building block of all proteins are amino acids. Go ahead and assemble your 4 monomer protein. And again, we have 1, 2, 3, and 4 monomers, 4 molecules, minus 1. That should give us 3 molecules of water. Okay. Number 6, assemble all remaining monomers into another protein. Same thing. Your bag might have like 7, someone else's bag might have 6 or 8. Just take all your amino acids and make a straight chain. Okay, you'll make a straight chain of amino acids. And everywhere that 2 amino acids touch, show a water leaving. Okay? Number 7. look up on Google the structure of a DNA nucleotide that's high school friendly. So find an easy picture. Try not to find one that's, the atoms arranged. Just find the molecules that make a nucleotide. So what are the, actually real quick, this part. The building block or monomer of nucleic acids are what? What is the building block of nucleic acids? The answer would be nucleotides, okay? And we're going to assemble a nucleotide. To make a nucleotide, you need to have three things. You need to have three components. The first one is a phosphate. Next, we have a sugar, specifically a pentose sugar. And the last one is a base, okay? Again, we have three molecules. 1, 2, 3. Minus 1, we should have 2 waters leaving, okay? So, the way this should look, when those bond, you have a water leaving the bond site. When the base bonds with the sugar, you should have a water leaving the bond site, okay? Your nucleotide should look something similar to that. Post-lab questions. I'm going to have you guys do this part on your own. I will give you a hint. The 4 macromolecules, or sometimes called biological molecules, I will tell you what they are. Number 1, carbohydrates. Okay. Number 2. Number 2 was lipids, or fats. The third macromolecule or biological molecule are proteins. And the last molecule, macromolecule, is nucleic acids. Okay? So tell me what their respective monomers are. And then tell me what they do. What is the function? Okay? Number 2. What process is being shown by water being given off from each bond site? Essentially what I'm asking, you can go back for your notes on this. What process links monomers together and gives off water for number 2? Okay. What process links monomers together and gives off water? And number 3 is the exact opposite reaction. What process is used to break down macromolecules or break down these polymers? Okay. And that's the end of this lecture, and I hope that was helpful, folks.